Here's problem number 4 from assignment 5. Um, we're asked to find for this ellipse where does it cross the x-axis, and show that the tangent lines at those points are parallel. Well, crossing the x-axis would be places where y is equal to 0. So let's go ahead and say with y equal to 0, we get x squared minus x times 0 plus 0 squared is equal to 3, which means x squared is equal to 3, which means that x is equal to plus or minus the square root of 3. So we're talking about 2 points. One point is negative root 3 comma 0, and the other point is root 3 comma 0. So there's our 2 points. Now let's find out whether those tangent lines are parallel. So we'll go ahead and take the derivative of that equation. Derivative of x squared is 2x, and I'll think of this as negative first times the derivative of the second plus the second times the derivative of the first, and then 2y is equal to 0. Oops, forgot the chain rule there. 2y times dy dx is equal to 0. We could, because we know these two values, plug them directly in to our equation and solve for dy dx. But since we have to do two of them, perhaps we're better off if we solve for dy dx. Let's expand this. Negative x y, or dy dx, minus y plus 2y dy dx is equal to 0. So this part and that part are going to go over to the other side, forming a y minus 2x. Let's factor this out, and we get 2y minus x dy dx on that side, or dy dx is equal to y minus 2x over 2y minus x. So what is the value of dy dx when we're at the point negative root 3 comma 0? We are going to get negative 2 times root 3 over negative root 3. Those cancel, we end up with positive 2. What is the value of dy dx when we're at root 3 over 0? That's going to be negative 2 times root 3 over negative root 3. Those cancel, leaving us 2. Because those two slopes are the same, the lines are parallel.